I guess I'll turn up this light. Okay, so we're going to do section 3.2, which is polynomial functions. And graphs. Okay. So the degree of a polynomial function is the highest exponent. Okay, so for example, all of the functions, sometimes we use the letter P for polynomial function. If I had a polynomial function of x to the 7th plus 3x to the 6th plus 5x squared minus 3x minus 2, okay, let's pretend that's my function. What is the degree of that function? And I'm going to ask a special thing because I really do want you guys to succeed. And I'm really getting annoyed with all the people that are on their cell phones texting, okay? Please put your cell phones away if you want to pass this class. If you don't want to pass this class, go outside. The class is not required, but I want you guys, I want your attention while you're here, okay? So put the cell phones away, okay? All right, now, what's the degree of this? I'm going to pick on Niels.
Would it be the x to the 7th?
So, yeah, we would simply say the degree is 7, okay? Yes?
Can we turn on the front light? It's really hard to see the board.
Oh, do you want to? Is that better?
Yeah.
Okay, it'll be worse for the video, but that's fine. Okay? We don't care about those people who aren't here that are watching the video. Okay? They should be here in class. That means you. Okay? All right. Let's see here. So, let's see. So let's do a quick review. If I have the function y equals x, first of all, what is the degree on this function? Jackson, 1. Degree is 1. Do you know what it looks like?
What it looks like?
Yeah, if I were to graph it.
Yeah, it's just a line going
Straight
up,
line.
diagonal.
Okay. Is that a polynomial function? Yeah. Kind of a boring one, but technically it's a monomial function. What about y equals x squared? The degree on that is what, Spencer?
2.
Okay. Degree is 2. And it looks like parabola facing upwards. Okay. Y equals x cubed. What does that, what's the degree on that? I won't pick on Caitlin, I'm going to pick on Mallory because she's eating.
3.
Degree is 3. Do you know what that looks like? Somebody called it the snake.
Yeah.
We'll call it the snake. That's good enough. Okay. Degree 3. Y equals x to the 4th. Okay. By the way, sometimes they refer to these as power functions. All of these. Okay. So this would be the power function on all these. Okay. Let's pick on Kelly. You know what that looks like?
What?
You know what y equals x to the 4th looks like?
I don't know what it looks like, but the degree is 4.
Degree is 4, she got that. Degree 4.
I don't know.
It's no longer a parabola, but it's kind of like a parabola. It looks like this, only it's going to be a little bit more U-shaped. Okay? Y equals x to the 5th. Okay? Let's pick on Berkeley.
5.
Degree is 5.
And it's a boxy stick.
More boxy snake. That's a good way to put it. Okay. So the bigger your degree, the flatter these things get, okay? Et cetera, et cetera. So sometimes we will refer to these as the end behavior. End behavior. Oh, I kind of did that, not on purpose, but that works out pretty well, okay? So you'll notice that if the degree is even, it's going to start high and end high. Start high and end high. If the degree is odd, such as 3 and 5, it will start low and high. Start low and high, okay? Now, this is going to be very useful as we get, these are non-shifted functions, and so this is going to be very useful as we talk about this. So, all right, so let's talk about the end behavior. What if I had a polynomial function that was minus 2x to the 4th plus 5x cubed plus 4x minus 7? Okay? All right, now, what do you think the end behavior is?
Down and down.
It's going to be down and down because I've got a negative here, right? So the basic x to the 4th is going to be like this. Now, the one other point that I will tell you here, the end behavior is going to be down and it's going to be down. We might not know what it'll do in the middle, okay? Now, the other thing that I want to point out here, when we talk about a degree of 7, what is the maximum number of maximums / minimums? You guys know? If you don't know, I'll tell you. It's going to be, yeah, it's always the degree minus 1. So it's the degree minus 1. Okay, so in this case, if it's a degree 7, you're going to have at most 6. You could have fewer than 6.
Are they 6? Like,
So in this case, so now I haven't talked about what does x to the 7th look like. What would be the end behavior of x to the 7th?
Would it be like a super fat snake?
It would be like a big snake, right? Probably going to look more like that, okay? Now, when we say that, that's why I said at most 6, okay? So it could be, we know that the end behavior is going to start low, it's going to end high. Now, it could be that we're going to get 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6. Okay? It could look something like this. I've got 1, 2, 3, 4, 5, 6. Does that make sense? Okay. We don't know what it's going to look like. The basic function is going to look like this, but if we start shifting it like we do here, okay, so the question is, we know the end behavior, it's going to start low and end low because of the minus sign on the leading term, right? What are the maximum, or what are the number of maximums and minimums? The highest number. Say it again. It's going to be 3, okay? So it could look something like 1, 2, 3. So it could look something like that, okay? Now, the purpose of this class is we want to be able to figure these out. And in calculus, we'll actually be able to identify where those are. In our class, what we're going to do is we're going to concentrate on where it crosses the x-axis, okay? So it could cross a maximum of 3 times. In this case, it only crosses twice.
couldn't it cross the x-axis way more than 3 times?
No, it's only going to cross a maximum. It's always going to cross less than that. So if I did,
Wasn't that the max number of minimums and maximums though?
yeah, it goes above.
Because if it crosses 3 times, it's going to have 6 like crossing points.
Oh, it could. You're right. It could cross a number of. Yeah. If I redrew it like this, It could have 4, yeah. So it could have 4 total places to cross, but it's only going to have 3 maximums and minimums.
Okay.
And
Okay.
the maximum, and minimum, that's how much it could have, not saying it will have that many?
Correct.
Okay.
At most. It won't have more than that, it could have less. Okay? All right. Okay, so we were off the screen there a little bit. All right. One more we'll do, and then we'll start looking at trying to find all the zeros. That's the fun part. Okay, so if I have a polynomial function p of x equals 3x to the 5th minus 5x cubed plus 2x. Okay, first of all, what's the degree? What are the maximum zeros or x-intercepts?
5.
And what are the number of maximums, minimums, the total number that it could be. So, whose turn is it? It must be Mallory's turn. No, I already picked on Mallory. We're going to pick on Caitlin because she had a mouthful last time. What's the degree?
So the degree would be 5, right?
5.
So you wrote it there.
Okay. What are the maximum number of zeros?
The maximum number of zeros would be 4, right? Or, no, it'd be 5.
It would also be 5.
And then the maximum ins would be 4.
4. And the end behavior. Let's talk about end behavior.
So it's going to be kind of like the same thing. So on the positive side, it'll be up, and then on the negative, it'll be down. Does that make
On the
sense?
positive side, the positive x's, it'll be up.
Yeah, and then on the
Negative sides, it'll be down. Okay? That's correct. Okay? Who studied with Caitlin? Okay, that's good. You guys are lucky. Okay? Yes, Berkeley.
This is just a question, but like, I remember we added, like, in my old classes, we like added all of the exponents together to get something, but I can't remember which, like each of the unuseful polynomials. Is that like a thing that we're gonna do?
I don't think there's any reason to add the exponents. I can't think of any reason why. Likewise. Okay? All right.
What's your real
I'm Andrew.
name? Andrew.
I go by Nate.
All right.
How do you get maximum zeros? I understand the degree, the maximum.
The maximum zeros are the same as the degree. Whatever your degree is, that's the maximum number of zeros. You might have less than that. Some of them might be real, some of them might not be real. Okay? So for example, let's pretend if this has 4 maximums and mins. So I'm going to go 1, 2, 3, 4. Okay, how many zeros do I have?
1.
I've only got 1
Because it's not.
right there. Okay. How many imaginary zeros do I have?
Probably a lot.
We've got 4. Okay.
So when you say imaginary,
So we could have 5 maximum zeros. In this case, we have 1 real and we have 4 imaginary.
so when you say 4 imaginary, does that mean if you were to try and solve for those other ones, you'd get like the square root of a negative number type of
Yes.
thing?
Okay. All right. Okay, let's see here. Let's talk about the intermediate value theorem. Okay. Intermediate value theorem. Okay. So the intermediate value theorem says if P is a polynomial function and P of A and P of B have opposite signs, then there exists at least one value C for which P of C equals 0. Okay? All right. So the idea here is, let's pick, this is A and this is B. Okay? Here's what the intermediate values theorem says. Okay? Now I don't have any numbers on here, but I want you to tell me if this is A, that's going to be P of A, right? And if this is B, that's going to be P of B, right? Okay? So, is P of A positive or negative? According to this graph here. It would be negative, right? P of A is a negative value. Okay? So in this case, it's a negative value. Is P of B positive or negative? It's positive, right? Okay? So P of A and P of B have opposite signs, correct? Okay? So if they have opposite signs, which they do, then at least there is one value of C in which P of C equals 0, and this is that value of C, where it crosses your x-axis. Okay? We can see that P of C equals 0 right there. Okay? Now let's pick a couple of different A's and B's. I'll do these in red. This is A, this is B.
Quick question.
Okay? Yeah.
Are these going to be values that are going to be dots that are given to us?
Yeah.
Or are we pulling?
Yeah, right now I'm
from the
just trying to
equation?
show you conceptually
Okay.
what's going on.
Okay.
And we'll start picking some other values, okay? So, red A and red B. Red A is negative. Red B is also negative. So is there a value that crosses the x-axis? Okay, no. Here's the problem though. Let me change my graph slightly. The idea here is you want your A and your B to be close together. So if I pick, what's my next color here? If this is A and this is B, well, either way, B or B. Well, we'll keep it that way first. Okay? Now that I've changed my graph, okay, this is A, this is B, this is negative, this is positive. There exists at least one, and in this case, there's more than one, right? There's 3. Okay? The problem is, what if I picked, run out of colors now. What if I picked this as my B? If this is my A, it's negative. This is my B, it's negative. It's hard to know if there is a 0 in between those because they're so far apart, right? So the idea here is, okay, if I pick two values, A and B, that are fairly close together, or even A and B, as long as the signs are different, I know that there exists a 0 in there. So the idea here is, even if it's hard to find these zeros, you can keep making it smaller and smaller, and then you can get so close that you can kind of figure out where that 0 is. Okay? So that's what the intermediate value theorem says. And this is used especially when these are complicated to find. You'll just keep shrinking this until you get right down to really close to where that 0 exists. Okay?
Is that how, could you find how many zeros there are by how many times the signs change in the, like the equation? Is that
Yes,
something-
that's called the Descartes rule of signs. We're going to learn that. I don't think in this section though.
Oh,
We'll learn that
okay.
in this class. Okay? Good question. And then one of my caps match. All right, so the idea here is, I don't think we're going to learn that in this section, but we're going to be able to take a function like this, and we're going to be able to tell how many real zeros there are and where they are. Okay? So let's do something.
But we won't find where they are.
We will find where they are.
We will today.
Yeah. Well, I don't know if we might.
Okay.
All right. So, all right. What if I asked you? We're gonna play a little Jeopardy here. Okay. I'm gonna give you the answer, and you have to give me the question. Okay. So, what if I said I want you to sketch the graph of P of X equals X plus 2 times X minus 1 times X minus 3. Okay? Now, before we do that, what is the degree of this polynomial function? The degree is 3. Who said that? Is that you, Texas? Okay. So x times x times x is x cubed. Okay, so do you know the end behavior?
Yeah, it's down and
It's going to start down, it's going to end up, right? So that's going to be helpful, and we'll move these around as needed. Do we know the intercepts? X-intercepts. What are they? Let's go with Hunter. You said -1, -3, and did you say -2? +2? Who agrees with them? Jonathan's disagreeing with you. What do you think, Jonathan? Yeah, you got all your signs backwards. It's +1, +3, and -2. Okay, remember it's in the parentheses, so it's going to be opposite. Okay? So the nice thing about this is +1, it's going to cross there, +3, it's going to cross there, and -2, it's going to cross there. Okay? Now that I know I know my degree, so I'm going to have how many total maximums and minimums? 2. Okay? So I'm going to redraw this something like this. Okay? And so I can get a basic idea. I don't quite know where that crosses, but I can probably figure it out eventually. Okay? So the purpose here is I want to make sure I've got all 3 of these zeros on here. I've got the end behavior and something like that. Okay?
do we ever find the local max or local mins in this class? Or were you saying that was calculus?
That's probably going to be calculus.
Okay.
Calculus, you'll find where those are. Okay? All right. Okay, so we're going to progressively get a little bit harder, okay? All right, so now let's go with P of X equals X cubed minus 2x squared minus 3x. Okay? I want you to find, I know the book always says zeros. I'll say find the zero. When you see that, you should think that means x-intercepts and graph. Okay? So let's pick on Ethan. Can you factor that?
So I pull out an x first.
Pull out an x first, okay? So x times what's left out?
X squared minus 2x minus 3.
Okay? And then can you factor this? Factors of x squared are x and x and -3 and +1. Is that what you said? Did that awfully quick. Let's make sure you're right. So that's -3 plus 1 is -2. Negative times positive is negative. That's correct. Okay? So you've now factored that. So your zeros are at where?
0,
0, 3, and -1. Okay, now, what's the end behavior? Just going to be like this one, right? Okay? So we've got zeros at 0, -1, and positive 1, 2, 3. Okay? So the end behavior is going to start low. It's going to go high. Just like that. Okay? I'm not too worried about where these locations are. As long as you get the basic shape right and you get these 3 points right, that will be good for the quiz tomorrow. Yes, perfect.
So there's like standard form, and then what was the other form?
Standard form and general form.
And then what's that form where it's like the parentheses? It's like factored.
That's just factored form, yeah. Okay? This is going to be ideal because it's going to make it a lot easier to graph if we can know that. Yes.
So just to be prepared for this stuff, so would you want the x-intercept represented like that x equals 2 and then just time listed?
Say that again.
So do you want the x-intercepts to be represented in essentially that form, just x is equal to whatever numbers we find?
Is it an acceptable final answer?
Oh, if I'm asking for the zeros,
Yeah.
You don't want us to write it.
that's fine. If I'm asking for the x-intercepts, I'll probably prefer to have them as ordered pair form. So the ordered pairs would be
0, 0,
0, 0,
3, 0,
3, 0,
-1, 0.
-1, 0. So either way, yeah. So if I'm asking for the zeros, that's fine. If I'm asking for the intercepts, that's
If
better.
find the degree, we're gonna use the first equation, not what we factored. Because then that degree changes to just 2.
Say it again.
When we find the degree, are we gonna find the first, we're gonna stay with the first.
Yeah, the
equation.
degree in this is 3,
Yeah.
and we're going to base that on that term right now.
Not just the x. just
Yeah. Now, if that has a 2 in front of it, what would the 2 do to it? It would make it, yeah, steeper. We'd go, in fact, if this is what it looked like, it would probably be something like that with a 2 here. If it was a 1/2 rather than a 2. I'm going to get my red out here. Get my caps on right. If it was a 1/2 x cubed, etc., then it would be flatter. It would probably be something like that. Does that make sense? Okay. All right. This
See that with the hammer.
Oh, thank you. Sorry, there we go. Now, here's something. This next problem is going to be a little bit rude, so I'm going to give you because they don't teach you this,
Now you're gonna use it.
and they're gonna teach it to you later, so I'm gonna teach it to you now. Okay? This is gonna come up in a future section, so I'm kind of surprised they put this one here. But let's say that I have here P of x equals negative 2x to the fourth minus x cubed plus 3x squared. I want you to find all the zeros and to graph this. Now this one has a little bit of a trick, and they don't really tell you what the trick is, but I'm going to tell you as we do this problem. So let's pick on, whose turn is it? I should really remember your name, and I'm having a hard time with it. What's your name?
Christian.
Christian.
Yeah.
Christian, can you factor that?
Yes.
Okay.
So equal a 2x squared out? No, just x squared.
Pull out an x squared, and you're left with,
Can you pull out a negative?
you could pull out a negative if you wanted.
Okay,
It's up to you.
Let's pull out negative.
Okay?
Then you're left with 2x squared, and then plus x, and minus 3.
Minus 3. Okay? And then can you factor that? Factors of 2x squared are?
Or just 2x and x.
Okay?
And then you have then do plus 3 minus 1.
3 and 1, you say it's plus and minus. Let's double check. Plus 3 minus 2 is plus 1. Plus times a negative is a negative. Perfect. Okay?
Okay.
So, what's your end behavior?
My what?
End behavior. What graph is it going to look like when I say end behavior?
Are they both going to be down?
They're both going to be down. So it's going to be y equals negative x to the fourth, right?
Yeah.
So it's going to be down because of this negative, right?
Okay.
Okay, so we know it's going to be down and down. Okay. Where are my zeros?
Should be a negative 3 and 1. Well, I mean, the x intercepts.
Negative 0.
Yeah, on this other one, how do you find the 0?
It's because the x is on the outside.
So for this one, is this one going to be 0?
Yeah, x is going to be 0, right? X is 3, x is minus 1.
Okay. So this one's a 3, and then a negative 1 and a positive. I mean, a negative 3 and a positive 1.
A negative 3 and a 1, is that what you said?
Yeah.
Okay, so remember when you're looking at this, that one assumes there's a 1 here, but there's not. So this is
So
not
it would
3,
be negative 3 halves.
negative 3 halves.
Oh.
Do you see that?
Yeah.
So it's like the whole thing equals 0.
Oh, okay.
Okay, now,
Yeah, I just.
okay, so we know that I've got a 0 here, and I've got negative 1.5. So I've got it here, so I'll slide that over. And I've got a positive 1 here, so I'll slide this over as well. Okay, now here's the tricky part. I don't think we teach you this for several sections. Okay, so I'm going to teach you this now. We'll probably learn this in a new section here. Okay, now there's a thing called multiplicity. Okay, so do you see how this is an x squared, Tim? Okay, if the multiplicity is even, it touches. If the multiplicity, and maybe I should spell out multiplicity is odd, it crosses. Okay? I'm sure we're going to learn that in the future section, but we don't know that. So the idea here is I've got a factor here with a multiplicity of 2.
So that's plus and minus.
Oh.
So it's going to touch the x-axis here. Okay. So let's go from here. So the leftmost point is negative 3/2, right? So as I come up here, the question is, am I going to touch or am I going to cross the x-axis? Okay. The multiplicity on here is a multiplicity of 1. 1 is an odd number, so it's going to cross. Okay. Now I'm going to come to 0. 0 has an even multiplicity. I've got an x squared term here. So what's it going to do? It's going to touch, and it's going to go back up. And then I'm going to go to the 1. 1 has a multiplicity of 1, so it's going to cross. Okay? Now, for some reason, they just expect you to know that, and then they teach it to you later. I don't know why. Okay? So I just gave you a nice hint that we're going to learn again in a future chapter. I gave it to you early because it's really helpful here. Okay, question?
The multiplicity, is it the exponential value?
It's the exponential. This is an x to the first. That's also an x to the first. This is an x to the second, right?
Oh.
It's the degree of that specific factor. That's what your multiplicity refers to. Yes?
Really quick, going back to the -3 over 2. So for this, like, for other equations, if it's set up like that, is it just whatever's going to be in front of the x over the, like, -3?
Okay, so to answer your question, whenever you have, so essentially these are 3 numbers multiplied together, okay? The idea here is when I'm trying to find where the y value is 0, I'm going to set this all equal to 0. So either negative x squared has to equal 0, or 2x plus 3 has to equal 0, or x minus 1 has to equal 0. Okay? Any one of these terms can be 0. Okay? So what I'm doing is I'm solving this. I can multiply both by a negative. X squared equals 0. X equals plus or minus 0, right?
Yeah.
Okay? 2x, I'm going to subtract 3. 2x equals minus 3. X equals minus 3/2. That's how we get that.
Yeah.
Okay? Over here, x plus 1. X equals minus 1. So those are your 3 zeros there.
That should be plus
Okay.
1.
Now, the funny thing is that you put plus or minus 0, but remember, the idea here is when we talk about this, this is a degree 4, right? Okay? So I've got to account for all of my roots. I've got 1 root here, I've got 1 root here, and I've got 2 roots there. That adds up to 4.
Say that again, actually.
Okay? I've got 1 root here. I've got 1 root here. Sorry, here. And then I've got 2 roots here, right? Because you've got, this says you have 2 possible solutions there. You can say plus or minus 0, but 0 is not plus or minus. Okay? So that's how this adds up. And so so this tells you the number of possible zeros that you have. Some of them might be imaginary. Some of them might be a double root. This is the same root twice. Okay? But these should add up to here. Okay? We're not going to deal with imaginary roots yet, but we will. Okay? All right, so the nice thing is we're still in real numbers. Okay? Question? All right. Let's see here. How about p of x equals x cubed minus 2x squared minus 4x plus 8. Find zeros and graph. Stephen, it must be your turn.
Perfect.
Any ideas?
Find the zeros.
Find the zeros, yep. That's what I asked.
Yeah. Now let's graph it. You do the first part.
Okay, you know the end behavior, right?
The what?
End behavior, what is this going to look like? as far as end behavior?
Like that graph?
This one here?
Yes.
No, it's not,
No. No.
because it's a different degree. What's your degree?
Snake degree.
It's the snake degree of the 3. Okay, so degree 3. So your end behavior is going to be y equals x cubed, right?
Yes.
Or sometimes we refer to that as the power function, okay? End behavior or power function. I could ask you either way, okay? Your power function is y equals x cubed. It's going to look like a snake, okay? All right, so now we need to know. So we know that it's going to be down and it's going to be up, something like that, okay? Question?
I was gonna say, like, on like quizzes and assignments and stuff, when you want us to, when it asks for the end behavior, you want us to write it as like y equals x cubed.
Yeah, that'd be great. Yeah. If I ask you for end behavior or power function, just write y equals x cubed. Okay? All right, so now he's got his phone out. He thinks he's off the hook, but he remembered that he was supposed to put his phone away because he wants to pay attention and get a good grade on the next test. And how do we find these zeros?
That's easy.
You got it.
Yeah. We just, you know, it's so easy to just slip my mind.
This slipped your mind. Here, let me give you a hand. What if we grouped these?
Yeah.
What if we did that? That might be helpful. Okay? Could you factor anything out of the first 2 terms?
X.
You could factor out an x squared, right? And you would be left with,
3 minus 2x.
nope.
Yes.
You pull the x squared out of here and you're left with
Oh, sorry. X minus 2x.
x minus 2. How about
Just
that? Okay? All right, what can you factor out of these 2 terms?
This is 4.
A 4, a negative 4,
Yeah.
and you're left with
X 2. X plus 2.
minus 2. Wasn't that lucky?
I did it.
Now, what can you factor out of both terms?
X into
X minus 2, right? You can factor this out of both terms, right? And you are left with
x squared minus 4.
x squared minus 4. Wasn't that lucky? Can you factor this?
Yes.
Okay, and you're left with, what does that factor into?
X.
X and X,
2 and
2 and 2, and the signs are
2. Minus.
plus and minus, right?
So,
Okay, are you with me? Okay, question.
I understand everything. We have 2 x minus 2s, 2 of those.
We have 2 x minus 2s, very astute. So I could rewrite this as x minus 2 squared, right? Times x plus 2. That's p of x.
No. I'm at the top. I'm not this fast. I understand x squared, and then the negative 4 becomes 1. And I understand you can factor those. But we have x minus 2 and x minus 2. How do you just go to 1? Like,
Okay, this factor is common to both, right?
yeah.
So I can pull it out.
X.
So I can pull it out, and I'm left with x squared minus 4. Okay?
Okay, I'll get that.
All right.
We can go.
Any other questions? Okay. All right, so I'm left with x minus 2 squared. What's the multiplicity on that? 2. What's the multiplicity on this? 1. Okay. So I'm at negative 2 and positive 2, right? I've got zeros here and here. Okay, I'm going to slide this over. Okay. Which one's which?
Crosses.
This one's the negative 2, right?
Yeah, negative 2
Okay.
cross.
At negative 2, do I cross or touch? I'm going to cross because it's got a multiplicity of 1, right? Okay, so I'm going to go up here. Somewhere I'm going to turn and I'm going to go to the,
And then that one's just.
okay, and this is a even multiplicity, so therefore it bounces, okay? And there you have it.
Wow.
I don't think you would have known that. It doesn't talk about multiplicity in here. Aren't you glad you came to class today? Okay, we will learn that in a future section, I'm sure. Oh, no, they do teach it, never mind. Okay, I didn't see it. All right.
Is there like a simple way, or like a little like out, like odd crossing even touches, or like a dear Aunt Sally, something like that?
That's your simplest way right there. If it's even, it touches. If it's odd, it crosses. Sorry.
I'll learn away.
I can't think of any other. I thought that was pretty easy.
Odd, 2 D's, crosses, 2 S's, 3.
Okay. Yes.
Is there any way you could do the first one that you had up there on the board? It was the 3x to the 5th.
3x to the 5th.
Minus 5x squared.
Or it was 3x to the 5th minus 3x cubed plus 2x.
I thought it was minus cubed.
It was when you were just talking about the general very beginning.
I think it was minus 5x.
Yeah, it's minus 5x.
Oh, that would make it solvable.
Oh, yeah.
Cool.
Okay, I was trying to figure that out. Never mind. I'm
Okay.
good.
Cool.
I wrote it down wrong. Thanks.
All right. So I'm feeling pretty good about 3.2. How about you guys? Ready for a new section?
Yeah.
Oh, that's good. That was a long section, and this one's a short one, so this is good. Okay? All right. So we're going to move on to 3.3. Which is long division of polynomials. Okay? All right. I've been out of school so long, I don't even know how they teach long division anymore, but hopefully they do it this way. So I want you to divide 6x squared minus 26x plus 12 by x minus 4. Okay? Now, here's how I want you to do this. So when I give you on the quiz tomorrow, this is exactly what I want you to do. So I'm going to take your x minus 4, and I want you to do a division sign, and then I'm going to do 6x squared minus 26x plus 12. Now, when you guys were in school, because I know you guys are so much younger than me, when you did 24 divided by 6, did you go 6 times 4 is 24, and then you subtracted it and got the 0?
Yeah.
Is that how you worked it?
Yeah.
You still teach that?
Yeah.
Because I can't say I'm a fan of this Common Core stuff. They don't teach that to you?
I just had calculators.
I got that last semester here, but not in high school.
You just had to
Common Core.
Your high school sucks.
That's fine.
Where are you
from?
All right. You went to Layton, really?
It's schools up there? I'm just kidding.
Wow.
Sorry, that was so rude. I'm so sorry. My middle name's Layton. Like,
All right, so hopefully, we'll see. Hopefully, my nephews went to Northridge, nieces and nephews, maybe they teach it there, I don't know, we'll see. All right, so here's what we want to do, okay? So the idea is it's gonna work the same way, okay? So x times what is 6x squared? 6x, okay? So I want you to write that there. So 6x times x is 6x squared. 6x times negative 4 is negative 24. Okay? Now, the idea here is I want you to subtract. Okay? So that means you're going to change 24x, yes. That means you're going to change these signs. Okay? So 6x squared minus 6x squared is 0. Negative 26 plus 24 is negative 2x.
Oh, yeah.
Does x go into negative 2x?
Negative 2
Yes, negative 2 times, right? Negative 2 times x is negative 2x. Negative 2 times negative 4,
It's positive.
positive 8. Okay, now I want you to subtract. So that means you're going to change both of these signs. Okay, negative 2x plus 2x is 0. 12 minus 8 is 4. Does x go into 4?
No.
No, this is your remainder, so this is plus, and this is how I want you to write your remainder, 4 over x minus 4. That's the answer.
Okay.
Okay?
Why would it be over?
One more of these.
Yeah, we're going to do another one of these, okay? Why is it? Because this is your remainder. So normally if I had, let's go back to here. We'll try to make this a little bit harder. 11 into 125. Does 11 go into 12?
Once.
It goes in one time, right? 1 times 11 is 11. I'm going to subtract the 11, right?
Yeah.
12 minus 11 is 1. Bring down the 5. Does 11 go into 15? Yes, it goes in one time. 1 times 11 is 11. I'm going to subtract. 15 minus 11 is 4. Does 11 go into 4?
No.
No, that's my remainder plus 4 elevenths.
Oh.
Okay, so it works the exact same way. Okay? You really didn't learn that late in high school?
No.
Wow.
I learned that in elementary school and then never actively.
Yeah, you should have learned it in elementary school. I
Yeah.
expected you to know that already, Lee.
Well, when you don't use it for
Yeah.
10 years, you probably.
Yeah, that's true. Probably don't use it for a while. All right, well, I'm glad because I will tell you, I had to teach a math for elementary school teachers, and they had all these really stupid techniques, and I'm just like, just do it the right way. Anyway, so here we go. Let's do another one. Here's what I want you to do. I want you to take 8x to the 4th plus 6x squared minus 3x plus 1, and I want you to divide that by 2x squared minus x plus 2. Do we have any volunteers that want to ace the quiz tomorrow that would like to volunteer? Okay, I knew I could count on Andrew.
It's me.
Okay,
4.
2 times 4, is it just plain old 4? 2 times 4 is 8, but what's x squared
We can
times 1 is x to the 4th?
We can add x squared.
X squared,
Do
okay?
you want to?
Yes, I do want to. We want these to match, okay? So 2 times 4 is 8. X squared times x squared is x to the 4th. Okay, now I need to multiply this 4x squared times negative x.
It's negative 4x.
Negative 4x to the 5th.
Fourth, third.
How about the 3rd? Okay, now by the way, I probably, in fact, this is a good thing here. When you're doing there's no x cubed term here, is there?
No.
Okay? What you might want to do so you don't screw up is put a 0x cubed there.
Oh.
Do you want me to redo that?
Can you read
Yeah,
that?
yeah.
Okay, so this is the problem they gave you, but I'm going to put plus 0x cubed, and now I got to find the rest of the problem.
Oh, it wasn't 6x cubed.
Yeah, it was 6x cubed. Or just not cubed.
6x squared.
Plus
Yeah.
6x squared minus 3x plus 1. Okay? So I will say that if they skip 1 like they did here, you might want to put a 0 in there just to keep you straight. Okay? Does that make sense? Because that wasn't in the original problem. Okay? All right. So now 4x squared times 2 is
8x squared.
plus 8x squared. Now, Andrew, Nate, well, I want to subtract, right? So that means I'm going to change all of these signs. It's going to make your life easier if you do it that way, okay? 8x to the 4th minus 8x to the 4th is 0. 0x cubed plus 4x cubed, 4x cubed, 6x squared minus 8x squared,
2x squared.
negative 2x squared, okay? Does 2x squared go into 4x cubed?
No.
Yes, it does.
2x times.
goes in 2x times, so plus 2x. 2x times 2x squared is 4x cubed. 2x times negative x,
It's negative 2x squared.
negative 2x squared. 2x times 2
4x.
plus 4x. Now I'm going to subtract, so I change all my signs. Negative, positive, this is now negative. 4x cubed minus 4x cubed is a big fat 0. Negative 2x squared plus 2x squared, 0. Negative 3x minus 4x, negative 7x. Plus 1. I'll bring that down to make it a little easier. Does 2x squared go into this negative 7x? So this is now my remainder, right? How do I write my remainder?
7x plus 1
Plus negative 7x plus 1 over
2x squared.
2x squared minus x plus 2. Sorry, I know that's terrible small. That's your answer right there. Okay? And hopefully you guys can see it. But if you were here, it would be easier to see. Okay?
Gotta make sure I don't mess up the signs.
Yes. This is a great place to mess up signs. Okay? Now, just so you know, the reason why we have this section is because we're going to be doing this a lot. Okay? This is to prepare you for the next section. Okay? Now,
I was told chapter 3 is kind of the foundation of the whole final exam. Have you seen the final exam?
I have not seen it, and I won't see it until probably the day of. Okay? All right, would you like an easier way to do this?
Yeah.
Okay? There's a thing called synthetic division. Synthetic division. However, there are some things. It only works if you have a 1x as your highest degree. Okay, so in this case, I've got a 2x squared. Can I do synthetic division on this one? No, I cannot. Okay, on this one that I just did, x minus 4. Can I do it on this one? Yes, I have a 1x. Okay, now, just for fun, what if I have 2x minus 4 here? Could I do it?
Yeah.
I could, but I'd need to make that a 1x. How could I make that a 1x? I could factor out a 2, and that would become x minus 2. Okay? So, so if you don't have a 1 here, you can usually make it a 1 by factoring that out. Okay? If I had, let's pretend this was a 3x. 3x minus 4. How could I make that a 1x? I could pull out a 3, and I'd be left with x minus 4/3. Okay? So I could make it work with this. Okay? Cannot make it work with this. Okay? Synthetic division only works if you have a 1 in front and the degree is also 1. Question? Okay? All right, so here's what I would like to do. I want to take this previous problem that I just did, and I want to do synthetic division. Okay? I'm going to erase this. Okay? So we know what the answer is. This is the answer. We're going to try to get that with synthetic division. Okay? Now, when you're doing synthetic division, this is the factor x minus 4. Okay? If you were to solve that for 0, the x would equal positive 4, right? Okay? So here's what I'm going to say with synthetic division. I'm going to pull out a 4 here. Okay? So it's going to be the opposite sign of whatever that is. Now, what I'm going to do is I'm going to write down all of these, and remember, just like we did here, and we had to add a 0 because there wasn't an x cubed term, I might need to add a 0 in this case. But in this case, what I'm going to do is I'm going to pull the coefficients out here. So this is a 6, a minus 26, and a 12. Okay, I'm going to draw an equal sign here. Okay? Now, here's what I'm going to do. I'm going to add down. 6 plus 0 is 6. Correct? 6 times 4 is 24. Negative 26 plus 24 is 2. 2 times 4, 8. 12 and 8. 12, actually.
Would the 2 be negative?
Yeah, this is negative 2. I knew I did something wrong. 4 times negative 2 is negative 8. 12 minus 8 is 4. Okay? So now, here's what this is. This is 6x minus 2 plus 4 over x minus 4.
How would you know to do the x minus 4?
Because this is your factor here. Okay? So I just did all this long division here. Isn't that a lot less space on your paper? I know some of you think that paper is going out of style, but this is save your paper.
So how would you know that that's the remainder? I guess I just don't understand.
So this last term is always the remainder.
Okay.
This is always the remainder.
So if it's like another thing that doesn't have.
So what if I get a 0 here?
And no remainder.
There's no remainder, and that means that this is now a 0 of whatever this polynomial term is. Okay? Let's do one more really quick. Okay? I want you to divide 2x cubed minus 7x squared plus 5 divided by x minus 3. And I want you to use synthetic division. Do I have a volunteer? Stephen. Okay. What's the number I put in the box? 3. What do I put over here?
2, 7, 5. 2, negative 7.
What did you forget?
The 0.
You forgot the 0. 0x to the first, right? Tricky, as the Run DMC would say. Okay. Now we're going to add down, right? 2 and 0 is 2. 2 times 3, negative 7 plus 6, negative 1. Negative 1 times 3, negative 3. 0 minus 3, negative 3. Negative 3 times 3, negative 9. 5 minus 9, negative 4. What does this represent? 2x squared minus x minus 3 minus 4 over x minus 3. Okay? So whatever you started with, you always go down 1 degree. Does that make sense?
If you do that whole last part like really slowly.
Really slowly.
So you gotta have.
We're out of time. If you want to leave, you can leave. We'll do it again though for those who want to stay. Okay?
There's 2, negative 7, 0, 5. I think.
3, 2, negative 7, 0, and 5. You're with me to there? Okay, I'm going to make you do it. 2 and 0 is 2. 2 times 3, 6. Negative 7 plus 6, negative 1. Negative 1 times 3, negative 3. 0 minus 3, negative 3. Negative 3 times 3, negative 9. 5 minus 9, negative 4. Okay, this represents
degree there. So
He just thought that.
2x squared minus x, and this over minus 3. Okay, we are going to do, for those of you who are still listening, we're going to do a lot of synthetic division. It's going to make finding factors a lot easier. Okay, a lot easier than going through all this, right? It only works if you have
But your brother, Dan, he's the right car.
Yeah. Yeah.